Another brainstorming session, and here we have with us Abhishek Dixit sir from Fujitsu. Please welcome him with a round of applause. I would also like to request Mayank Narayan Singh sir to present a bouquet to sir. So please join the stage, sir.
Good afternoon, everyone. In the morning, I had a small discussion with Vivek sir, and the IT as a technology, or how the world is moving towards, the newer and the future technologies. Be able to do the justice for the time and the opportunity being given to me. Okay, so just one slide on Fujitsu. So Fujitsu is around a $42 billion organization. We are the fourth largest global IT company, largest in Japan, and we are the fourth largest IT services company also in the world. We have close to 100 odd data centers globally, and our operations are in approximately 115, 120 odd countries. So this is one of the very latest thing which has been done by Fujitsu, and this is not just by Fujitsu. This is being done as a project by government of Japan with an institute which is called as AIST, Advanced Artificial Intelligence, Science and Technology, blah blah blah. That's the institute name, and this is one of the largest AI-based supercomputer in the world. Okay. And why I'm showing you this slide, that there's a big discussion, there's a big shift, and there's a big work which is happening right now globally in the field of AI, And since I am a hardcore, person who has worked in this industry for last 12-13 years, and out of the 13 years I have been very closely associated with the high performance computing industry, AI is very close to that spectrum. So what I'm going to talk about today is a very few slides on AI. What are the next and new generation technologies that are coming up? Probably in the field of quantum computing, probably in the field of data center technology, in the GPUs arena, and also what Fujitsu is trying to do globally as far as the leading technologies are concerned. So what we do, so when I say AI or HPC or big data in terms of technology, these are the industry-wide spectrum that you can see where these technologies can be used. It could be used in space, advanced science, manufacturing, weather, chemistry, bio, research, universities, companies, national projects. So all this is something which is highly, utilizing the AI, HPC, simulation, and cloud as a technology. Okay, and probably I am right now the gathering is there. Who are the people who are sitting here? Probably are from the leading research and the research labs in the country, and probably you have the big onus on yourself that you are the one who brings and who creates the niche in the market. In terms of the technology innovation, which are the biggest adopters of the latest cutting-edge technology. You talk about quantum computing, you talk about AI, you talk about big data. All this has happened in some or the other universities. It's not been developed by any industry per se. Industry has adopted something which has been created by you guys from all of your universities. Okay, and probably then it comes back. It is a co-creation activity that happens with the industry and the academia, and that's how the new technology get developed and it benefits the society. So what we think, ultimately it's a circle. It's the circle that the technology being developed, the newer thing being developed by you from the academia side, it's went to the industry, and then it goes to the society. So in this chart, what we are trying to show actually is all the advanced computing technology is being utilized on the data side. So now the data becomes the key, and then they are getting accessed or analyzed via these newer technologies. It could be AI, it could be big data, it could be simulation, it could be analysis. and then all this information is going and getting benefited for the return to the society in the use of some benefit. So that's the whole crux. How we see it is that everything is being done to solve a problem, and what to solve and how to solve a problem is by making our life better. Probably what AI is doing is we are trying to use AI in the medical field so as to make our life better. We are trying to do HPC so as to bring newer and better materials for our space engines or for our cars or so and so forth. So the ultimate reality is resolving around the society. So again, this is all about co-creation. So co-creation starts from your end, moves towards the industry, and then delivers to the society. So what is my agenda? So my agenda is not here to talk about the hardware. Hardware is something which is agnostic. What I want to tell, probably what my message is that hardware is just one part of the whole spectrum. It is the research. So what I look at is empowering researchers and connecting them to the cutting edge research. Okay, attaining the best TCO, resulting in competitiveness and ensuring self-reliance. That's the key message. Whatever technology we buy, whatever technology we invest in, and whatever activity we want to do. So keeping that in mind, I have listed out few of the things. Probably I'll take two slides on each. So this is a project being done by a government of Japan that started in the year 2010, and this is called as RIKEN system. Okay, the lab name is RIKEN, and the system is called as RIKEN post-K product development. When RIKEN started this project in 2010, their objective was to develop the 9 areas of science. Okay, they did not start it, and these are the 9 areas of science where they started with. They did not went to a hardware vendor or said, I'm trying to do something, give me some hardware. They said, okay, fine. These are the 9 areas of science where we want to do our research, where we would like to invest and see, and how does it benefit the society. So these are the 9 areas of science on which they started their journey. Okay, and what Fujitsu brought in was, what Fujitsu brought in into the whole spectrum was the co-development of the science plus the associated technologies around it. Okay, so the objective was to develop a technology which is working in collaboration with the science. The IT part of it was absolutely dependent on the science that was being done. These were not two independent spectrums. Unfortunately, what happens typically in our country is that IT becomes separate and science becomes separate. And then we try to bring both of them together rather than taking both the things along. So the approach here was to build a system or build a technology, keeping science and IT infrastructure both together. And the result of that is Fujitsu. Unfortunately, I have to bring Fujitsu every now and then because I'm talking about what we have done as an organization. Fujitsu is going to deploy an exascale system in RIKEN in Japan, where we are using a completely newer processor technology. It doesn't talk about Intel, it doesn't talk about AMD, it doesn't talk about power, it doesn't talk about Spark. So Fujitsu has chosen ARM as a technology, ARM processor as a technology, make it optimized for HPC, did their R&D on it for almost 5 years, and they are deploying a system which is going to be the first exascale system deployed by 2020. And why we have chosen this system? Major 3 factors. How does it work for an application? If a particular application is embarrassingly parallel, then the processor should be capable of doing that. if A application is dependent on what vector components, so the processor should be capable of doing that. And it also includes a lot of balancing, because we are talking about close to 300,000 systems put across in one single image. So what does it mean that we developed a whole new system, and one of the biggest factors was the power envelope. Because when you talk about an exascale system, you're talking about 300,000 nodes kind of an architecture. So one of the biggest factors was how to keep the power envelope lower. Any Intel processor that we talk about right now is 150, 180 or 200 watts. Probably the next one, which is the Cascade Lake, is going to come, is going to 120 watt per processor. Why we choose this? Because the existing system which is there in RICN is around 13 megawatts and delivering around 14 petaflop kind of a requirement. We want to keep that power envelope, we want to keep as close to as that power envelope and deliver a system which is to the exascale level. Because power has become a major challenge for approximately for all the systems in the world. All the data centers which are there in the world needs to have much more larger capacity, IT capacity in terms of whatever power or space they have. This is one of them. So second one, what we did, we are coming out with our own deep learning processor, which is more like a co-processor. This is called a DLU. Again, why we are coming up with this? Because here again the factor is the performance and the power. If you see any current generation AI-based processors which are there, the power envelope is around 500 to 600 watts. What we are trying to do is that in the same power envelope, we are trying to reduce it by 10 times. So that's the reason why we are again coming up with something which is, and this is specifically meant for deep learning activities. So some of the basic core components like TensorFlows and so on and so forth are built around it. Last but third one, Fujitsu. So quantum computing. I'll not name Fujitsu, but quantum computing is the next big thing which is happening globally. Lot of research, lot of R&D, lot of organizations are trying to do big on quantum computing. Why quantum computing? Because right now, if you probably, I can give a very basic. This is how I understood why and how quantum computing is working. Is right now everything is to the power something. If you have a third other than 0 and 1, if you have something which is like a superimposed condition of 0 and 1 both, if you have something which is 3 to the power n, so you have automatically increased your computing power by 1.5 times. And it's a math. It's a very, very complex math. So the objective is that what Fujitsu and to create a quantum computer is like very, very tough, because the environmental condition has to be 0 gravity. That's the number one, and the temperature has to be 0 degree Kelvin. So it's like it's like next to impossible to create such a superimposed condition. But yes, there are organizations which are doing that. What Fujitsu has done that since to make it so has to have a step in between the two, we have created a digital annealer, which is a quantum simulator. It's a physical system which has, right now the system is having 1024 bits. The next generation, which is getting launched in 6 months, will be having 8064, I think 8000 plus bits. So 8000 plus bits is almost if I talk about 1000 bit system right now which Fujitsu is having, and it's a digital circuit, it's not a quantum circuit, it's almost 17,000 times faster than the normal processor, than the normal computing. So if 8,000 bits which they're talking about probably is even much more higher than that. So, and this is typically being utilized for solving salesman's problem, and so it's being utilized heavily for solving the complex mathematical problems. So this is the next thing which is done by us, and this is the where industry is also moving towards. Okay, so this is a very if anybody wants to have an access of the system, yes, there is a possibility of giving access to such a system. The middleware is being designed by a company which is called as 1Qubit. This is the same company which is designing middleware for any other quantum computer. So this is just a slight intro on that. So the objective was to show something what is the next thing happening in the market. Now when I started this presentation, I did slightly talk about the data center. Okay. I'll show one video of 2.5 minutes probably, and that will define what I'm talking. So what I'm going to speak, because I have a lengthy slide, but I don't want to show that, but I'll speak for 2 minutes. Any data center which is there is facing major challenges because of the power envelope. You have 100 kilowatt capacity, and you want to put more and more system within that 100 kilowatt capacity. You have a limited space, and you want to keep as many systems possible in that limited space. Then you have existing data center which is 10-year-old, and you want to utilize that same data center continue for next 10-15 years. You don't want to invest in a data center because that's the operational cost, and probably you would like to save that money and invest in something which is more beneficial in terms of compute or something else. Fourth thing is the environmental conditions, the dust, the arid natures, the proximity to the sea, the kind of humidity, and all these are factors which really hampers the productivity of a data center. So Fujitsu, again, unfortunately I'm naming Fujitsu, but this is the roadmap which is being there in the industry for last 40 years. And the cooling technologies have been developed over a period of time by this way. So everybody is probably using a cracked unit in their data center which is typical air cooled. Then the in-row, which is known to everybody. The self-contained one is like you have everything built in inside our system, but it's again air cooled or water cooled mix. Then the rear door heat exchanger. Then fourth one is like coiling based, this is oil based technology. Then the direct on-chip cooling technology. Then comes the immersion cooling. So Fujitsu is working on something, not working, but we have, it's the next big thing which is happening in the industry, is the immersion technology. You actually, the component which is generating the heat, if you dip that entire component itself into a system which absorbs the heat completely from that system, without getting in touch with the contact like water or air and so on and so forth, you are absolutely ensuring that the system reliability increases, the power consumption goes down, and the space utilization also increases. For these systems, so if you are seeing immersion cooling, with immersion cooling we are actually talking about 90 kilowatt per rack capacity. And with the current generation system, 90 kilowatt per rack is very much possible. If you populate a full 42U or 44U rack with each node having 2 GPUs, each view having 2 GPUs, you're having almost 80 odd GPUs, and this 90 kilowatt per rack is easily achievable. Okay, so all this is probably in the range of 10, 20, 25 kilowatt per rack kind of a capacity. But suddenly there's a big jump because the power utilization itself is moving towards that direction. I'll show you a video, and that will help to understand what immersion technology is probably all about.
The exponential growth of data and stable operation of virtual systems require high-speed, efficient, and cost-effective data centers. More servers and rapidly growing performance requirements lead to a continuously increasing demand for power and cooling. Traditional high-density IT rack deployments do not provide sufficient cooling for higher-performing servers. Limiting rack density is required to cool higher-performing servers, leading to increased data center size. A new paradigm in data center density is required to solve the challenges of exponential data growth. The Fujitsu Liquid Immersion Cooling System. With extensive experience in liquid cooling, Fujitsu introduces the next stage in extreme cooling technology. The immersion of servers in a dielectric fluid to drastically improve cooling performance. Immersing servers in a dielectric fluid provides greater cooling efficiency, eliminates the need for server fans, and reduces cooling equipment power requirements by 40%. This leads to high-density server deployments that decrease floor space requirements by 50% compared to traditional data centers. We just need a slight modification to current air-cooled IT equipment to realize the benefits of liquid immersion cooling. Maintenance of immersed IT equipment does not require additional human resources, and concurrent maintenance is available. It's as easy to maintain as air cooling. Liquid immersion cooling protects equipment from harsh environments, allowing deployments anywhere. It enables flexible expansion for exponential data growth. Next-generation data centers are the foundation of a hyper-connected world, can be located anywhere, and are made possible by Fujitsu's innovation. Fujitsu Liquid Immersion Cooling System.
Yeah, so this system is already deployed in India at one of the very premier institutes. Yeah. So I have few more slides on my third topic. I have 10 more minutes, I think. Okay. So AI. I think one of the most talked topic in the industry right now, and suddenly this topic in last 2 years has become very pragmatic, and everybody wants to know about it. Everybody wants to talk about it. This is a Gartner chart which we are showing, and if you see this red mark popping up, it all talks about the emergence of artificial intelligence in a lot of the industrial usage. You talk about the medical, you talk about the autonomous vehicle, you talk about the medical field, you talk about the industrial automation, you name it, and a lot of people are making a lot of investment, a lot of people are making a lot of understanding how to use AI as a technology. So AI is not just about the work of science. Probably it has now started impacting our personal lives as well. Probably you have seen the examples of Alexa, Siri, and Google Assistants, and these things are becoming very in thing right now. You talk about image recognitions, these scannings that keep on happening at the airports, the railway stations, and probably this is being widely utilized in other countries, but in India it's still the things are happening. But I see a lot of activity in and around the image recognition and so on and so forth in the education field. Robotics is next big thing. Text and translational activity being done by MHA, the NTROs and the defense and so on and so forth. They're widely started using some of these newer technologies. In terms of industry, retail, automotive vehicle, healthcare, government, finance, tax are some of the places where again it is being widely utilized. And why it has become prominent? Because there's a big interest shown by the scientific community, the academia, the research institute have really shown a lot of interest into something like this. Okay, so different organizations are doing this AI as a technology in different ways. For example, just to name IBM, IBM has developed a Watson system, which is like a cloud activity where they have deployed a huge supercomputer, and utilizing that, they are doing all their AI related activities on that. I have seen most of the educational or research institutes or the IITs, they have their own systems being deployed in their labs or in their data centers, where they are utilizing smaller systems to develop the algos around it. Okay. Okay, so artificial, so I think artificial intelligence was always there in the industry for more than 50 years, but probably it was more relevant in the form of machine learning. Machine learning was very popular even now. Why suddenly artificial intelligence has become a big success in the industry is because the computational capabilities of the IT infrastructure has become equally powerful, so that they can process, or they can understand, they can process the data which is available. In a nutshell, for any artificial intelligence or a machine learning activity, data is the key to success. If you have data, the same data can be trained, and the same data can be further utilized for giving inferences out and give a proper result. And since probably 10 years back, the IT, the hardware industry, the systems were not so powerful that they can process that humongous data which is already available with us. If you see the kind of data which is being generated these days, it's like massive. The social networking data, the scientific data, the simulation data, the data which is probably, even if an aircraft is flying, the kind of data which is generated and the kind of information which can be gathered from it is like massive. And if you process that information, it was lying probably in our data centers for ages, but nobody was utilizing it to get the results out of that data. If the very classic example is this: if you study a weather pattern for last 50 years on the current date in Varanasi, that was not possible 10 years back. But now that kind of image, satellite imaginary activity is possible. The processing of that is possible. If you process an image, then how to do the results oriented activity from that particular images is also possible these days. So the core activity, if I break up this artificial intelligence, the two core activities are the deep learning and the machine learning. Machine learning is definitely at the core, and this activity is majorly done in most of the IITs and the premier institutes. So artificial intelligence is all about sense, reason, act, and about. So it's all about decision making. How if there are two options which is being given to anybody, then the machine itself should be able to give the intelligence to trigger an action. So that's more like an artificial intelligence. The classic example is the autonomous car that we're talking about. If the autonomous car sees a person who's trying to hit him, if a car is going to hit a person, the automatic reaction is the stoppage of that particular car. So that's the core of artificial intelligence. Before that comes the machine learning activity. So that process is done through a machine learning algorithm which is built inside that whole autonomous vehicle as a car itself. In the current scenario, all these autonomous cars you see, one of the major challenges is that the computing system has to sit inside the car itself. It's still not possible that you have a cloud-based initiative which can trigger that automation. So all that processing has to happen real time on that car. So probably industry is moving towards that kind of a technology where the computing can be done on something as an edge kind of a network, and the autonomous trigger can happen with that particular edge component itself, rather than having the whole processing unit sitting inside the car. So then so machine learning is all about algorithms, and then then comes the deep learning, the neural network part, which is the model, the training of data, and the inferencing. As I said earlier, this all has become possible because of two things: more and more availability of data, and secondly, more and more powerful systems. And HPC, in collaboration with AI, is doing a really great job into it. So yeah, so this is one slide which shows the difference. So classic machine learning is the algorithm-based activity, but the moment you talk about the deep learning activity, you have the training as a step. The first step is the data training, and then the outcome is the inference, the actions around it. So this is a little bit more getting into the details. Yeah. So in a nutshell, data and strategic data acquisition and processing is the key. And as now I'll just simply say one thing, that Fujitsu as an organization has an understanding of this data, has an understanding about the strategic data that can be acquired from that information, has an understanding about the machine learning, the deep learning activity, and also has the understanding about the infrastructure, hardware infrastructure that needs to be built around it, so that all these can be done, and you as the research community can get the benefit and output from that. Probably this is the last slide that I would end up. Okay, I think I'm on time. Thank you.
More such sessions on this. As a token of respect, I now invite Professor Vivek Singh sir to present the shawl and memento to Abhishek Dixit sir.